So the sum and difference formula for sine is the sine of alpha plus or minus beta is equal to the sine of alpha times the cosine of beta plus or minus the cosine of alpha times the sine of beta. We use sum or difference formulas to help us find exact values of things like the sine of 75 degrees. Since 75 degrees would be the same as the sine of 30 degrees plus 45 degrees, these are common angle measures and they add up to be 75 degrees. So we can use this formula up here to give us an exact answer. So that's going to be sine of alpha is the first angle measure, beta is the second. So that's the sine of 30 degrees times the cosine of 45 degrees. Now, when I use a plus right here for a sum, I use a plus right here for a sum. So I'll say plus cosine of 30 degrees times the sine of 45 degrees. The sine of 30 degrees is 1/2. Cosine of 45 degrees is square root of 2 over 2. Plus the cosine of 30 degrees is square root of 3 over 2. Times the sine of 45 degrees is square root of 2 over 2. Alright, so that's the square root of 2 over 4 plus the square root of 6 over 4, or the square root of 2 plus the square root of 6 all over 4. Let's take a look at another problem. Let's look at the cosine of 105 degrees. I'm sure there's several ways. I can think of a couple different ways that I could get 105. But I'm going to say that's the same thing as the cosine of 135 degrees minus 30 degrees, because these are both common angle measures. Alright, so the formula for cosine is very similar to the one for sine, at least the format is. The formula for cosine is the cosine of alpha plus or minus beta is equal to cosine of alpha times cosine of beta minus or plus sine of alpha times sine of beta. So if I need to use a difference to get to this angle measure, then I need to use a plus between the two terms. Alright, so make the first angle measure your alpha and the second your beta. So this is cosine of 135 degrees times the cosine of 30 degrees plus the sine of 135 degrees times the sine of 30 degrees. Okay, so to find the cosine of 135 degrees, the easiest way is to use a unit circle. Go to the second quadrant, and at 135 degrees you have the point negative square root of 2 over 2 for the x and positive square root of 2 over 2 for the y. So if I want to take the cosine of that, cosine is the x value. So cosine is going to be negative square root of 2 over 2, the cosine of 135 degrees. The cosine of 30 degrees is square root of 3 over 2. The sine of 135 degrees, again, I would use a unit circle, go to 135 degrees, and look at the ordered pair, then use the y term, since we want to know the sine. So that's positive square root of 2 over 2. And then the sine of 30 degrees is 1/2. Alright, so this is going to be negative square root of 6 over 4 plus square root of 2 over 4, or negative square root of 6 plus square root of 2 all over 4. Or you could factor out a square root of 2. You could also factor out this negative sign, or you could just rearrange the terms. I'm going to rearrange the terms first, and now I'm going to factor out a square root of 2. That'll leave me with 1 minus square root of 3 all over 4. Alright, let's look at this problem. The sine of pi over 12. It's pretty hard to figure out what two angle measures, when you add them together or you subtract one from the other, would give you pi over 12. So what you might want to do, if it helps, at least until you get used to these types of problems, is change that over to degrees. So what is this angle measure in degrees? You say 180 degrees divided by 12, and you're going to get what? 15. Alright, and so there's a lot of ways I could get 15 degrees, but I'm going to say the sine of 45 degrees minus 30 degrees. It should work either way, whatever you pick. All the positive and negative signs will work themselves out, but 45 minus 30 will give me 15. So now I'm using the difference for sine. So look at your formula, and when you subtract here, you also subtract in the formula. It's the sine of alpha, so the sine of 45 degrees, times the cosine of beta, so the cosine of 30 degrees. And then since I use a minus here, I use a minus here. And then cosine of alpha, that's the cosine of 45 degrees times the sine of beta. That's the sine of 30 degrees. The sine of 45 degrees is the square root of 2 over 2. The cosine of 30 degrees is square root of 3 over 2. And I have minus cosine of 45 degrees is square root of 2 over 2. Sine of 30 degrees is 1/2. So that's square root of 6 over 2. Over 4. Minus square root of 2 over 4, which is going to be square root of 2 times square root of 3 minus 1 over 4. Alright, if I wanted to find the cosecant of pi over 12, that's sine's reciprocal, I can use the answer for sine to help me figure out the answer for cosecant. So what I'd want to do is I would want to take the final answer for sine and flip it. So I'd have 4 over square root of 2 times square root of 3 minus 1. I wouldn't want to leave radicals in my denominator, so I would multiply those out. That'll give me the square root of 6 minus square root of 2. And then I would multiply by the conjugate. So multiply the numerator and denominator by square root of 6 plus square root of 2. Alright, if I do that, I'm going to have 4 times square root of 6 plus square root of 2 over, now multiply your denominators together. Multiply the first terms and the last terms, because the middle terms are going to cancel out, which makes this thing simplify and look a little prettier, in my opinion, because now you have a 4 in the denominator. And so now you have square root of 6 plus square root of 2, or square root of 2 times square root of 3 plus 1. That's your final answer.